I'm Brad Blissit, President of Integrated Structural Concepts, and this class is Residential Multifamily BIM plus IPD, Processes, Workflows, and Benefits, Module 1. This virtual class provides real-world examples of how residential multifamily structural engineers and trades are using Building Information Modeling, BIM, for wood frame projects. Integrated Project Delivery, IPD, processes and workflows have been developed to streamline design and construction. This technology is based on Autodesk AutoCAD architecture and Revit software, which are integrated via model map technology. The model map files can be exported to truss and wall component manufacturers to eliminate the interpretive redraw process. Structural engineers can now visualize, design, and draft in 3D while collaborating with teams of suppliers and trades. Material lists can be exported for quantified value engineering. BIM-based off-site construction techniques linked to models can be used to accelerate project schedules. Using BIM and IPD at design provides valuable data and critical path information, offering a win-win scenario for the owner as well as all participants. At the end of this class, you will be able to understand the usages and technology for wood frame BIM systems, understand the processes, workflows, and benefits, while understanding the direction the industry is heading. The technology for residential BIM has seen a dramatic acceleration in the past 3 years. Today, complex single-family and multifamily projects can be modeled both architecturally and structurally, including every structural item from anchor bolts to roof sheathing. BIM for wood frame structures allows the structural designer to collaborate efficiently with the architect as well as the owner, trades, and suppliers. The problems of the past have been the lack of interoperability between different software platforms, where an architectural model could not be shared between engineer, truss designer, or trades. This lack of collaboration creates problems in developing a fully comprehensive set of construction documents. In the examples we will show later in Module 2, we explore the uses of BIM and IPD, which harnesses the power of technology, combined with dynamic cross-functional teams. Some of the topics we'll cover include the need for BIM, the benefits, costs, where to start, IPD, and the future of the technology and integrated processes for the construction industry. In the traditional delivery model, design principles work independently to create construction documents that will be released to the trades and supply chain for multiple rounds of budgeting and bidding. The selection process is typically driven by the low bid. Value engineering and collaboration is rare due to the competitive bid scenarios. Any changes after award are driven by RFIs and change orders, which can cause delays in the construction process. New techniques such as IPD and Design Assist eliminate the RFI and change order process while providing valuable input into the project design by specialists in each given field or trade. BIM for wood frame projects is virtual construction. This includes 100% accurate structural engineering, including studs, plate, plywood, hardware, and trusses, all in 3D, with as-built accuracy. Foundation models can include all geometry, post-tension cables, hold-downs, and rebar. MEP such as ductwork and critical path plumbing can be included. The typical wood frame project undergoes 7 to 10 redraws. Costs associated with plan review and resubmittal fees can skyrocket on large projects. The deferred submittal process on a large project can include hundreds of truss components for review. How can these structural components be reviewed properly in a just-in-time procurement scenario? RFIs take up enormous resources for the trades and suppliers who have to generate them, as well as the responding parties and the general contractors who have to organize them and make sure they are followed up on. Rework and change orders cause exponential losses, including loan expense and rent revenue lost due to construction delays. Seeing is believing. Mistakes can be eliminated by implementing BIM for wood framing. By integrating architectural design with structural design, each element can be analyzed and visualized for constructability issues. This process allows for a comprehensive set of construction documents to be prepared. Better plan development means less risk to owners. Today, models can be imported to time and cost modeling software, adding another usable layer to BIM. Bill of material reports can greatly enhance current estimating practices by providing empirical data. What does it cost, or how much does it save? When compared to typical 2D plans, 3D BIM contains more information, more detail, and data. 2D plans with equal detail and data would have similar overall cost. What are the true costs of doing it wrong in the field? The risks grow exponentially for owners when construction does not go according to plans. Interpretive measures cause defects and delays. The go, no go decision to try BIM on any project doesn't need to be an excruciating process. Level of development is the only real decision that needs to be made. Architects that are BIM savvy can easily develop a massing model at very low cost. Structural engineers can design typical units in BIM, and trades can run initial framing and mechanical layouts to determine best systems and practices. One building or the entire project. BIM offers several entrance points to determine the design and construction team's ability to interoperate using the technology. IPD revolves around teams being brought to the project at inception, specialists bringing critical path decisions at the right time before any design development processes are key. Cross-functional teams include members with unique skills and the ability to put the project before themselves and their respective firm's needs. Investing in BIM is no easy decision. Hardware upgrades, software purchases, training, implementation expenses, combined with loss of billable production can prohibit entry into the BIM world. Today, the marketplace is changing to allow more use with less upfront costs. Hardware continues to improve and become less expensive. Software providers such as AutoCAD have revised models to allow subscribers to upgrade annually for fixed maintenance fees. Productivity gains increase exponentially as users and processes become more efficient. Will your firm be BIM capable? Or more importantly, will your competition? A tremendous amount of money and energy has been spent to integrate BIM with the job site. Companies such as Trimble and Leica have developed technology that allows BIM models to be imported into robotic total stations in order to lay out critical path items. GPS devices can integrate with optical devices, and the intelligence is hardwired to allow multiple users with the same technology on the site without interference. Tablet-based computing will provide a myriad of uses in the field. IPD begins at inception, utilizing teams. This moves the workload forward in the process, which requires an earlier investment. The traditional process has construction documents being revised and resubmitted as RFIs are submitted by the trades and suppliers that change the design and scope of the work. Trust encourages taking risks, facilitates information sharing, and enhances productivity. Trust works to eliminate conflicts. Trust allows each team member to be transparent. Trust breeds integrity and accountability. A team that has developed trust guarantees results. IPD team structures for multifamily projects would be represented in this diagram. Information would flow freely through the project management team and core IPD team using BIM. Lean construction techniques include Six Sigma principles where systems and processes are analyzed by defining the issue, measuring the variables, quantifying the data, improving the design, and controlling the outcome on the job site. Today's budget-conscious owners are aware of the paradigm of you get what you pay for. Time spent developing plans can be a rushed and fragmented process. Budgets or costs fluctuate as designs are revised as they progress from conceptual drawings through permitted construction documents. Solving the problems associated with a multitude of pricing exercises rarely adds value to the project. BIM for the wood frame market sector has been slow to be developed. The cost of developing the technology and allowing it to be used by the masses had to be balanced by the return on investment. Several entities had to join forces to share the burden of software development and integration with mainstream AEC platforms. This lack of tool sets was combined with the fact that most established AEC firms had some 2D tool in place and a process developed that allowed them to use 2D efficiently. The residential and multifamily markets have been one of the biggest resistors to change. Owners were unaware of the technology, contractors resisted the investment, and trades could not effectively use the information in the field. Today, the game has changed. The benefits that BIM plus IPD will bring to the residential multifamily construction market are undeniable. There are several camps throughout the U.S. and abroad who are working diligently on BIM technology. Integrated software platforms appear to be the goal of those who would like to dominate the BIM markets. Manufacturing links that allow CAD to CAM, computer-aided manufacturing, also appear to be a must-have, as cheap labor will continue to disappear and projects become ever more complex. Most sizable product manufacturers are busy developing content to be used in the BIM models to allow their products to be specified and gain market share. This has been Module 1 of BIM plus IPD for residential multifamily processes, workflows, and benefits. Thank you.